Hello everyone, in today's video I'm going to be taking a look at the TEVO Tornado, which is a large budget-friendly 3D printer that was recently sent to me by TEVO for review. Starting with the unboxing, everything was packaged very nice and secure with foam padding. Nothing appeared to be scratched or damaged during shipping. All of the parts, hardware, and tools needed to assemble the printer are all nicely organized into separate bags. The printer comes almost fully assembled. Just a little bit of easy assembly is required to get the printer up and running, as you will see in just a minute. The main components of the printer are basically packaged in two separate sections. The lower parts of the frame that contain the build platform is in one section, and the upper part of the frame as well as the power supply are located in another section. Here's a look at everything out of the box. The included assembly manual is well written and included some useful images, making the assembly process simple. I started by carefully securing the upper section to the lower section using the bolts specified in the manual and making sure that it is oriented in the correct direction. I then installed the T-brackets onto each side and verified that the upper section of the printer is at a right angle to the base and isn't leaning to one side. I verified that all of the bolts on the printer's frame are tight and that everything is square. The printer I received had a few bolts connecting the frame pieces that were loose and needed to be tightened. With the printer's frame now fully assembled, I was ready to get everything wired. This again was very easy as all of the wires were either labeled or, in the case of the bed and hot end heaters, each contain a different number of pins so that they cannot be plugged in incorrectly. The instructions made it clear which connector goes where. I noticed that a few of the connectors for the end stops and stepper motors didn't seem to want to securely snap into the sockets. While most of the connectors had a satisfying click and the connections felt solid just like you would expect, a few of the connections felt very loose in the sockets despite being pushed in all the way. Fortunately, after many hours of printing, I've not had any issues with any of them coming loose. After connecting the power cable, the final thing I needed to do was mount the print bed. I couldn't find any mention of this in the manual, but fortunately it is very simple and straightforward to install. After removing the twist ties and foam piece that was underneath the bed, I used the bolts and adjustment nuts in bag A5 to sandwich the yellow spring between the bed and the support. I also removed this test print from the bed. The surface of this bed really provides a lot of adhesion. A razor blade and a scraper really come in handy for removing parts. With that complete, I powered on the printer for the first time. The printer can be monitored and controlled from the screen and dial located on the front of the box. Using the commands indicated in the manual, I began leveling the build platform by moving the nozzle to different positions around the bed, and then adjusting the 4 screws on each corner using a piece of paper to help gauge the distance. After this, I was ready to print. One minor inconvenience that I have noticed with my printer is that if I insert an SD card while the printer is powered on, it never seems to recognize it. In order to use an SD card, I have to insert it before powering on the printer. Then the printer will recognize the card and I can begin printing from it. I'm not sure if this is typical or if there's an easy fix for this. I have tried using different SD cards, though it's the same result no matter which card I use. One thing to note is that no filament holder is included with the Tornado, though a STL file for printing a holder is provided on the included SD card. I've just been using a filament holder that I already had on hand. And that is all there is to getting the printer up and running. It shouldn't take more than 20 or 30 minutes before you can begin your first print. Before I showcase some of the items that I've printed, I first want to quickly talk about some of the specs for this printer. One notable feature is its large build volume, measuring 300 by 300 by 400 millimeters. This printer also has an AC heated bed, which allows it to heat up very quickly. I was able to heat the bed to 70 degrees Celsius in just a few minutes. One drawback of this, however, is the slight but potential shock risk if a wire carrying this current were to fail and come into contact with a metal part, such as the support below the bed. The easiest way to help reduce this risk, and is something that I will be doing soon, is to install a strain relief bracket for the bed, which will prevent its movements from putting stress on the solder joints. Also make sure that there is nothing for the heated bed wiring to get caught on while it's moving. The only way to completely eliminate this risk is to completely shockproof the printer by grounding it. There are some well-made videos and articles explaining how to do this. This printer uses a Bowden type extruder accepting 1.75mm filament, which can easily be inserted by pressing this tab and pushing the filament all the way to the hot end, or for removing the filament when changing color. You can also rotate this gear, which makes it easy to purge the nozzle. According to TEVO, a wide variety of different materials can be used, including PLA, ABS, PETG, and even flexible filaments. As of making this video, the only material I've had a chance to test is PLA, though I will be experimenting with different materials in the near future. I'm especially curious to see how this printer handles flexible filaments, as these are typically difficult to use with a Bowden extruder. The maximum hot end temperature is 260 degrees Celsius, and the printer comes with an MK8 0.4mm nozzle. The maximum layer resolution is 0.1 millimeters, maximum printing speed is 150 millimeters per second, and the recommended printing speed is 60 millimeters per second. The printer can be operated by connecting it via USB to a computer, or with the on-screen controls and a G-code file on an SD card. The frame and all the mounts are aluminum, though there is still a bit of flex in certain parts, though this can easily be addressed with some simple modifications. This is just a brief look at some of the general specs. If you'd like to get more information, you can check out the links below in the description for more details. So far, I've put over 100 hours of print time on this Tornado, printing a variety of different objects with the intention of testing this printer's capabilities. These are a selection of some of the objects that I've printed so far. As I said before, all of these objects were made from PLA, some were printed with more premium brand name filaments, while others were printed with cheap generic filament. A wide variety of both free and paid print preparation software can be used with the Tornado. All of these models were sliced in Simplify 3D, using the preloaded settings for the TEVO Tornado that can be accessed via the configuration assistant. I only modified some of the settings slightly for certain models, but otherwise I did not change any of the preloaded settings. The first model that I printed was a 20mm test cube. The surface finish of the cube looked great, and the dimensions were very accurate. Just a little bit of elephant's foot and outward flaring on the top few layers were the only imperfections. Using the same higher quality filament and preloaded Simplify 3D settings, I printed a 3D benchy. Overall, the print turned out nice, though there are a few small blobs around the openings of the cabin area, as well as these lines visible towards the top of the cabin. This printer also shows what is commonly referred to as a salmon skin effect, which is a subtle but visible texturing on the surface of the parts. This texturing can be eliminated in a number of different ways, probably the easiest being to install some smoothers, which are installed between the board and the stepper motor, something that I plan on doing at some point in the future. Next, I printed Make Magazine's torture test print. Overall, the printer did a decent job, though it did struggle a bit with the arch, and some minor uneven layering and blobs were once again visible. After that, I did a Z-axis height test by printing a narrow 10x10 by 350mm square pole. The part looked great up until about 180mm. From there and higher, it starts to get a little wobbly. I also printed out this rocket that is a similar height, but being much wider does not show the same wobbling that the previous object does. After making a few tweaks to the settings and reducing the layer height to 0.1mm, I printed out this 1/10 scale racing seat. It turned out nearly flawless, and the layers are only slightly visible, though the salmon skin effect is quite prominent. All in all, a great looking print. To see how this printer would handle a more detailed object, I printed out this bust of Albert Einstein, once again at a 0.1mm layer height. Although there are a few gaps and spots, which can easily be corrected with a few small adjustments within Simplify 3D, the finished part looks great and shows a nice amount of detail. Supports were used when printing this object. Next up is this LS3 engine block. As you can see, this object contains a lot of overhangs and details, making this a fairly challenging print. This also took over 40 hours to complete. The result looks decent overall, however there are some issues when looking at it from the bottom. Some adjustments need to be made to the print settings in order to help eliminate the poor surface finish over areas where supports were used. Aside from this, as well as a few other minor imperfections, and a few spots where it appears there was some inconsistent extrusion, it's a decent print that I'm confident could be made even better with some adjustments to the settings. Finally, I printed out all of the parts for a 1/10 scale RC crawler frame. I thought this would be a good test to see how the printer handled parts for an assembly that need to be dimensionally accurate. All in all, the parts turned out very nice. It appears I had the nozzle a bit too close to the bed when printing the frame rail pieces, so the bottom several layers are wider than what they should be. As a result, I needed to do a bit of sanding in order to get them to fit properly. I also needed to widen some of the holes. As you can see, these M3 nuts fit into place perfectly. The frame went together without any trouble. It's straight, dimensionally accurate, and feels sturdy. For all the models that I showed previously that are not my own, I'll be sure to include links to them below in the description. So far, my experience with the TEVO Tornado has been very positive. I haven't experienced any mechanical issues or any failed prints. I'm not a huge fan of the bed surface. Removing large parts in particular is a pain due to the strong adhesion, and I found it more difficult to get a smooth and consistent first layer. I certainly don't hate the surface, but I'd much prefer a conventional glass build plate. I'll probably end up converting this to a glass build plate at some point in the future. This printer is fairly loud, though I wouldn't say it's significantly louder than your average FDM printer, but it's certainly something to keep in mind. There seems to be a large and active community of TEVO Tornado owners, and because of the printer using common parts, maintaining and repairing it shouldn't be too difficult. There are also a ton of modifications and upgrades that can be done to the Tornado. Although I plan on keeping mine stock for the immediate future, I do eventually want to do some upgrades as well. To conclude, so far the TEVO Tornado seems to be a solid, budget-friendly printer featuring a large build platform and an all-aluminum frame. The ability to print from an SD card, as well as to make adjustments and control the printer using the control box, is a nice addition. The quality and surface finish of the parts that I've printed so far using PLA have turned out great, though there is certainly some room for improvement. I think it's important to note that there are a lot of variables when it comes to print quality. The quality of the filament, print settings, and how level the bed is are just a few things that can play a huge role in the quality of the finished part. This is the case whether you are using a lower cost printer such as this one or a much more expensive machine. In order to get the most out of any printer, you are going to need to spend some time experimenting with different settings and getting all the mechanical aspects of the printer dialed in. It has been a number of years since I have owned or used a printer in this price range, so unfortunately I don't really have anything to fairly compare it to, and I don't know how the Tornado stacks up against other printers in this price range. Though so far, I do think this printer would be a good option for any hobbyist, new or experienced, looking for a solid budget-friendly printer, utilizing common inexpensive parts, and that has a large build volume. Is this the best printer for the money? Unfortunately, I really don't know. I look forward to continuing to experiment with different settings and different materials, as well as to make some modifications further in the future. Of course, I'll be sure to keep you all updated here on YouTube and on the other social media pages. As I said previously, this printer was sent to me at no cost by TEVO for the purpose of making an unbiased review. I have not received any payment to make this video, and all of the opinions expressed are my own. The only thing they asked was that I include several non-affiliate links to their store and to the official TEVO Tornado Facebook group, which you'll find below in the description. One thing to note is that I believe the newest model of the TEVO Tornado is gold instead of green, like the version that I have here. Anyways, that is all for this video. Thank you all very much for watching, and I will see you next time.